But yeah, okay. Let me send a link again just in case. Cool. 115. Distinct subsequences. Given a string s and a string t, count the number of distinct subsequences of s, which equals t. A subsequence is a string of a string is a new string which is formed by the original string by deleting some or none of the characters without disturbing the relative position of the remaining characters. Okay. Yeah. Also, one thing that I've been meaning to practice is just uh, um, dynamic programming and Python in general. I feel like it just I'm just way more I don't know better about the uh, in other languages. I guess that's all. Okay, let's just say n is equal to lambda. Which one? S and T. Okay, say n of t is equal to n of t. Maybe afterwards. Oh, does that work? Huh. I guess so. That makes sense. That would actually. I'll have to think about it. But thanks. Uh, I think I'm just. It's just more that like I'm used to being really precise with DP arrays. But yeah. Um, though yeah, it is a little bit. I don't know. It just always feels a little awkward to write when you try to write bottoms up versus top down. I don't know. But also, I think I need to do +1, especially in stuff like this. Oop, um, okay, so now I have the array set up. Um, so basically, you want to find T and S. So that means if a character is correct. So what are the transitions? The transitions are for two indexes. Um, so one thing that I'm trying to be better at is doing bottoms up. I think I could do this top down very quickly, but I'm trying to skip that, practice skipping that step a little bit. Um, so what are the transition in this one? So for index ij, um, if they're equal, then it adds. That means there's a path to the end. Okay. And then you goes to okay, something like that. That should be okay. Okay. So then in that case, your base case is if they're both at 0, there's one way to get there, and everything else should be well 0. And then now you do for was it just ij, but that's maybe a little confusing. Uh, +1 for j. Oops, I like skipping words when I'm typing. +1. And any other case, is that okay? I'm also just thinking about what other 0 cases, but okay. I'll just start from 1. Yeah, okay. If s I minus 1 is equal to t sub j minus 1. I think this is also a symmetric. Is it a symmetric one? Yeah, I guess this is a symmetric one where it doesn't really matter the order of the loops, except for maybe memory considerations if you want to do that, because in theory you could actually optimize this to use the last two arrays already. I do notice that these optimizations, but I'm not gonna do that. So, at least not yet. Maybe I'm forced to, but then, oops, yeah. -1, j -1. Otherwise, uh, Otherwise, you just skip a letter in S. So let's just say J. You can do is that right? Yeah. Can you skip a letter in T? I guess you can't skip a letter in T, so maybe that's right. And then now it's just TP and S and T. Maybe something like that. Am I? I feel like I'm maybe missing a transition, but that's kind of what it. Oh, did I? I always. That's my thing, is that I always get the index wrong on the double thing, because this should be columns in the inside. I always mix them up. Okay, it is wrong. Okay. I'm missing a transition. I feel like something's missing. So let's take a look at the DP array. So it's, I think I don't have great base cases for zeros. Maybe I needed them to be ones. Yeah, I think that's what I'm missing. I need to be able to start from a non-zero thing. So that means this thing is a little bit off. I mean, it's I needed a little bit more, which is from NS. I okay. Yay! First try, not bad. And again, you could save some memory by noting that this only ticks on the last. Maybe I could have done that optimization actually. It would have been trivial. But I think one thing that I was focused on for viewers who might not watch me struggle with dynamic programming problem, one thing that I am trying to be better at in general in person, which maybe I didn't come across explaining that enough, is that I'm very used to doing things top down in terms of dynamic programming or memorization, if you want to call it that. But one thing that I am trying to be better at is just bottoms up programming, dynamic programming, which I used to be okay at, but I feel like I've been just using the top down as a crutch and never really practicing it. So I think I'm definitely trying to do that here. But yeah, the transition for this one is that if two characters are the same, on the ith and the jth index of the s and the t respectively, then which you could count to the previous one and then just count them together. If not, then you skip it. You could only skip from the s, but not the t. Hence, this asymmetry on this, because you don't add from the j minus one, and it actually becomes a little bit similar to what you call it, binomial numbers kind of, except for with this constraint, and also setting the right base case. I was actually thinking about this while I was typing it, but it took the test case for me to be convinced that, well, because it was wrong, that I needed to be a little bit more, which and some of that helps if you kind of visualize this. If you're able to visualize this as kind of well, when how many ways are there to get from to match the up to the ith character of the zeroth yeah, with the zeroth of the second string, and the answer is one, right? And you cannot skip string on the t string, so that's why you don't do the symmetric thing of also initializing the j element to of that, and requires a base case. Hey, what's up? Yeah, so it's kind of like, sorry, I'm going back, try to screw top down. Yeah, so it's kind of like sliding window by the entire row by keeping track of just the last two rows that you've edited. What's up? Bruno Kazui. Question is, when did Python add types? I don't think these are real types. Actually, I don't. So the short answer is maybe Python 3, but actually I haven't read up on all the new Python 3 stuff. I think these are just suggestions. So like you could still pass in anything and then maybe it'll still work. I don't know. Maybe I'm wrong about that one though. So someone with better Python 3, let me know. But I do notice that it's something that shows up in Python 3 from time to time, especially in the, and this is because it's pre-generated template for me, because I still don't write Python 3 this way. That's my bad. But uh, get a padded out of bounds because they're set to 0. Yeah, exactly. Because if you get used like -1 or something, like you don't get an exception, which in Python is also a little weird because -1, especially like wraps around, which is or like counts from the back, if you will, which is always a little annoying. But hey, what's up, UK Chang? Can I show or can you? Well, you asking, can I show how this could be done with top-down DP? Yeah. Yeah, exactly. Sorry, I'm answering also. MBAX, yeah, exactly. It's a diction, not an array, so you don't get out of array of bounds. But if you're doing testing, sometimes you get quote unquote lucky and get the right answer, but not really. Yeah. I think so. Yeah, UK Chang or UKC Hang. Anyway, uh, yeah. So I think the key thing to I mean I the reason why I think I want to explain this point a little bit better is, and this is a great example is to do it because even though it's a hard, it's a very standard hard, and I think if they were to ask this problem now on Leetcode, like on a contest or something, it's probably like like a medium at hardest nowadays because it has gotten harder for it is what it is. But the reason why I can do things top down memorization a little bit easier is hey, what's up, Tux11? It's going okay. I'm just explaining dynamic programming. But yeah, I think some people think about dynamic programming problem differently in different ways. I think for me, the reason why the top down is more kind of, I wouldn't say attractive, but more intuitive for me is because you could write a function that encapsulates all your states in a very clear way, especially base case. Like in here, if you look at bottoms up, like this base case, it may not be entirely obvious unless you already thought things through. But here, if I have like, okay, let's just say, let's say I have a function that's, memo, let's say s index, right index. So these are my sorry, t index. So these are my parameters and these are my states. Well, in this case, you already know that. Well, like what do you know implicitly or explicitly maybe even? Well, you know the s index. Well, it's going to be between 0 and the size of s. Yeah, I mean I think that's obvious, right? Because that's the point. And similarly for t, right? So these are things that you could check for very easily. Where in here, maybe you have to be a little bit careful about the bounds, which is maybe not hard, but for this particular case. But there are cases where there are more nuances and there are more kind of conditions, and you have to. It's just a little bit more confusing to do. But hey, what's up, Tux11? Hey, it's been going well doing dynamic programming, so I'm going to try to explain this. But feel free to ask any questions if you have some. But yeah. But so that's one. So and then it also force you to add, to kind of think about the base case immediately, and that's one of the first things I do. Is like, okay, well, what are the base case? And in this case, it is symmetric in a sense that you go forwards or backwards, and it doesn't matter. Like in a string, as long as you're consistent about it, like you can reverse one string but not the other. But in that case, it's symmetric. So you could depend. So it depends on how you want to construct the problem going forward or backwards. But let's say you're going forward, which is something that I do. Then you know that well, if s index is equal to n, say, I mean in this case it's ns, then you know that it is done. So you're like, okay, in this case, let's just return 1 because that means you. That means that you matched. Oh, sorry. I guess actually, no, the other way. Sorry. Which is why the base case is more intuitive when you're doing it forward. Is that okay? If t index is equal to n sub t, or like the size of t, let's just say this. It's usually we, right? You return 1 because that means that you went through every element of the T array, and it doesn't matter how deep you are in S, as long as you went through every element of T, it's 1, right? So that's kind of the way I think about it. Yeah, and there's some mapping to mathematical function that I think I just have more information on. But then on the other hand, let's say this is not true. If T index is not at the end, sorry if I'm talking too fast. Slow me down if I'm talking too fast, by the way, because I think like sometimes I talk too fast because I have a lot in my head I'm trying to get out. Because sometimes I don't talk too fast. But yeah, in the other case, right? Let's say T index is before the end, right? Well, if the S index is equals to the size of S, well, we know that it's done, or like we know we have to return because we can't just keep on, or then like no more characters to match, right? So then in this case, you return 0. So these are your two base cases, and it's just more intuitive to think about it this way. But yeah. Yeah, I also agree that bottom up is the way to go. That's why I'm trying to practice a little bit. But the specific question was if how it could be done with top down, which is why I'm explaining it. But also just kind of because I think sometimes when I'm like solving a problem, I don't explain it that much because I'm like cranking it and just making assumptions about what people understand. So I'm trying to be as forward as possible, especially on a problem that is relatively straightforward. But yeah, but okay. So now those are your base cases. I hope that's okay. EK Chang, let me know if that's, you know, this part is okay for now. And let's say that's that, right? Well, then what's next? What's next is, well, there are only two possibilities in this case, right? It's either if S of S index is equal to T of T index, or it's not, really, right? So there are only really two cases for obvious reasons, because what else are you doing with S index and T index, right? So yeah, oh man, you know, I always have this rant on greedy. I actually am way better at dynamic programming than I am with greedy, because greedy requires you to prove stuff, and I'm always like, is it greedy though? And I'm always not 100% sure. But yeah, but in this case, you're like, okay, well, if the indexes are correct, then then you know you actually return, you know, then there are two possibilities. If they match, then you could either use the current S character, or you don't use the current S character, and then you save it for the forward, and then you keep the same T, right? So so that's kind of like the idea here, between here where okay, so you use this S index, or you don't use the S index, and or you don't use this current index, so then you're still at the same T index for that result. And similar, and if they don't match, then you can't use it anyway. So you have to go look at the next one. So that's kind of your combinations. I didn't actually do the memorization, because that's just more code. But but that's basic. I mean, you could write the memorization part. I trust you, UK Chang. But that's kind of the idea behind how I would think about how to think about solving this dynamic programming in top down. And that's kind of essentially the way that I solved this. Um, Except for I think I did it in theory. I counted the other way, with the base cases. Technically, I did it backwards but forward. I did it backwards and reverse, if you want to call it that, which makes the code a little bit confusing. But yeah, yeah, definitely take a look at it again for the greedy stuff. But yeah, but that's how you would do the. That's how I would put down the top down recursive function, and obviously you can memorize this very quickly. I mean, it's just on these two numbers, and you can also prove that because you know you're memorizing on this, and you do this constant space, or constant space, constant time, and you have the length of S times the length of T. So that's kind of your complexity and space. But yeah, but that's all I have for this problem. This is a standard dynamic programming problem. I'm not actually not a fan of dynamic programming problems on interviews. I feel like it's a little bit too much. And that's just like very, very basic like Fibonacci number type thing almost. Um, and maybe this one is also kind of straight, like I don't know, I don't want to say straightforward, but it is standard-ish. Um, but otherwise, yeah. So I don't know, but if you feel like you're strong on the other stuff, then this is probably one of the earlier problems of dynamic program problems that I would kind of practice on. This is the subsequence or the string ones, which are usually n times m or n square or something like this. Those are very common interviewee problems if they're still doing dynamic program problems. So I would recommend it. Um, but yeah, that's the kind of things that I would talk about it. Uh, cool. Uh, yeah, and if you're doing competitive programming, this should be a standard for you, just because they're going to ask you harder questions. But yeah, uh, cool.